right? And then, so in the last session, we were, we'd started chapter 2 of the study guide, and we were looking at the different operators, different Java operators. We were mainly looking at binary and unary operators, and it was quite a sort of technical session with lots of different rules and things. But if you look at the Java doc that we put in this binary operator tester, most of those rules are summarized here about those rules of, if you remember, rules of like precedence when you have a long expression, and also of arithmetic promotion. So obviously won't go through it all again because that was the last session, but if we just home in on one example right at the bottom here, and I think if you follow this example and what it's doing and step by step, then you've pretty much understood everything from the last session. So it's a horrible looking expression. I don't think you'd ever see one like that in the real world, but just to go through it, if we just look at this expression to start with and look at this bit afterwards, why are we bothering to do that? So we've got an expression here, and we're step by step here we're showing how it gets evaluated. So if you remember the rules, it goes from left to right like we do normal maths, but there are various precedences that come into play. So for one thing, when you have a unary operator like you've got here, that's an increment and decrement there, they will get evaluated first before the binary ones. So there's a binary one there, multiply, a divide, a plus. And then when it comes to the binary ones, the divide and multiply will happen before plus. So if we just go through it step by step, we're told that x starts as 3. So the very first thing it'll start to evaluate this expression. It'll go left to right, and it'll say, yes, this is a unary expression, do this first, and this is a pre-increment. So what it'll take x into its own little world for a minute. It'll think, okay, yeah, so this is a pre-increment, so we'll turn it into 4, then we'll put it back. So that becomes 4 multiplied by 5. So then it goes along and it finds this one here, and this is a post-decrement. So it says, so again, it takes that out and it says, okay, I'm going to decrement it, but I'm going to do it after I put it back. So it puts it back as 4, then it turns it back to 3 again. And this one then is a pre-decrement, so it takes 3 and turns it to 2 and puts it back again. So you end up with that, and the unary operators were done first. Then the binary ones kick in. So obviously it'll do this first. 4 times 5, so you end up with 20, and then divide that by 4. And then finally add the 2. So I've just rushed through. Obviously, we did the whole hour last week on explaining why all those rules apply and why that does what it does. But that kind of just recaps that. And then what we're doing, it would be far easier just to assign this to an int. But we're just demonstrating the principle that one of the rules of promotion is that as soon as anything smaller than an int, like a short, is involved in like a calculation, like an expression, it automatically gets promoted to an int. So the whole of that could really, you could do that straight away as an int. It'll be, and that's what you would in the real world do, of course. So if you just call it something I probably haven't used, D probably, D. Leave it there. So what you could have done straight up, it looks a lot simpler. Still looks nasty, but it looks a lot simpler if you do that. My int. There we go. My int 2 then. I've obviously used all these variables before, have I? Okay, mate, 22. There we go, 222. Right, so that works straight away. If you did that as a short, it wouldn't work because all of this arithmetic that's going on here means that these will get promoted to ints, even though they start as a short. So that's why we do that casting there. And if you remember, it's not really a good idea to do that casting there, because you're basically going against what the compiler wants to do. Because you might, for example, fall victim to the I think it's called overcasting, where you'll fill up the short, then start again from 0 again, so you get a nonsense answer. But anyway, I won't go into that. So that's all in the session from last week. But if you sort of read that and kind of make sense of how it works, then you've pretty much understood everything from the last session. So we did unary and binary operators last session. So let's move on to some of the other ones. And I think there's lots of these different test classes to go through. And once we've done those, we've done the vast majority of chapter 2 really. So I think the first one to look at is a nice simple one. It's this compound operator. Again, I've tried to put the Java doc in all of these classes. It's just these compound operators. So it's basically like to operate one of these binary operators combined with the equal sign. So there's 4 different ones to cover. So let's just quickly look at those. So basically, you've got int x is 3 and y is 5 here. If we do that, this is the compound operator. It's basically it's exactly the same as saying that, but it's just a shortcut way of doing it. So if I just print that, might look a bit strange at first. Okay, just create that. Just run that. So there we go. So y is 15. So y equals x. So y equals itself, which is 5, multiplied by x, which is 3. So it makes 15. It's just exactly the same as doing that. It's just a shortcut way of doing it, really. So if we do that instead, that should also print 15. Just the shortcut operators. Yeah, and that's all there really is to it. Obviously, we've demonstrated the multiplication ones. You can do it with all those other ones as well. That's all it really is. But there's just a couple of things worth mentioning about it. Is all that business that we've been through in the previous session about when you multiply, when you try to assign an int value to a short, it won't compile, and that kind of thing. And when you try and do mathematics on these things, it will promote shorts to ints. This kind of gets round that in a way. So for example, here we've got a short and an int, and we're saying make this short be equal to itself multiplied by a, which is actually an int. And because of those rules, that won't compile because what it's trying to do is it will evaluate that as an int, and then it's trying to assign it to a short there. So that doesn't compile. But this, which is essentially the same thing, it doesn't. It does it anyway. It kind of takes that into account. It realizes that you're using one of those things, and it's it allows you to do that. You can get away with it. Similar thing with exactly the same principle here, but this time with a long and an int. We can't assign a long value to an int without first casting it to a long. But if we just use this compound operator here, it gets round that. So it's pretty simple compound operators there. You sort of get used to them, and they don't have these casting problems here. So that's that one really. So just to start on, I'll start on this one, and then it gets a bit complicated. So I'll start it and go to something else, then come back. But this is equality operators. There's only 2 of them: equals, and like exclamation mark equals, and they're just testing for equality. So as they're testing for equality, they return a boolean. So they either say yes or no, true or false. You're saying is this equal to that? You either get a yes or no back. That's what they return. So if we look here, for example, and the thing is that when you go to the exams and things, they always try and trip you up by confusing you with the equality operator there. So sorry, with the assignment operator. So we use equals in Java, just a single equals, to assign something like that. So that's saying that the integer called 5, we're assigning the value of 5 to it. So when you have 2 equals, that means you're testing something for equality. So if we see here, for example, we've got 2 integers here, and they've both been assigned the value of 5. So if we say, does 5 equal 5 more? Does it? That's the equality operator there. So for that, we'll expect a true or a false to that. So just run that one. you know, expects true or false, and it's true because they're the same thing here. This really is just a revision of what we talked about in some of the earlier sessions, where it looks a bit weird, and I've never really seen this actually done in this sort of real commercial Java. But you can assign, so you're declaring a new variable there, and you're saying assign it to the same value as 5, which is there, and while you're at it, assign the value of 5 more to that and that. It sort of works kind of, you know, recursive, like chain and chained way. So you chained assignments. It's just a little like a nod back to what we did in an earlier chapter. But anyway, all those ints now equal 5. So this is going to, let's have a look. Yeah, so that's this time we're showing the difference between the equality operator, which is that, and the equals, the assignment operator there, because this returns a Boolean, but here the assignment operator just literally assigns something. So you've just assigned the value of 5 to that operator, and it just reports it there when you try to print it out. Just showing that you have to just spot the difference between what that is and what that is. That will always return a true or a false. Here again shows the difference between those two, and we're just introducing what a basic if statement looks like. That'll come in later on. Sorry, Richard.
Yeah, on line 37.
37, yeah.
If you only had 1 equals, that it always evaluates true.
If you only had 1 equals, that would fail. That would fail compilation.
Oh, really?
There, you see, because the reason it fails compilation is because an if statement, and we haven't actually dealt with them yet. We'll deal with them pretty soon. An if statement requires something there that evaluates to a Boolean. So it requires something there that's going to say true or false, because you're saying if this, then do that. So you can't. It's meaningless if you have something there that returns an int. Say it has to be something that's yes or no, true or false. So you have to have that in there. So you're saying it if x equals 5. Well, we know it doesn't because we've assigned it to 1. If it equals to 5, it'll go in there, and else it'll go in there. So we know it's going to go in there because x doesn't equal 5. So it's just most of you will be perfectly familiar with if statements anyway, but this is just a little nod to it. So yes, it's gone into the second one there. Obviously, if we made that 5, it'll go into the first one hopefully. So there we're doing an assignment, and there we're doing a check for equality. I'll just turn it back to 1 again. So that's that. And yeah, so at that stage, there's more to say about equality, because what we've essentially looked at just here is checking equality in primitive variables. We've only used ints actually, but all these like 5 more x here, they're all integers, but it's exactly the same principles apply to all the other primitive types. But you can also use this equality operator, this equals operator, with objects. So I'm going to come back to that in a minute. But you can see here we're looking at some objects. So this is a file object here. I'll come back to that in a minute. Just a couple more to do first, and then we'll come back to it. So if we go to relational operators next, then so a lot of these you'll just be familiar with in just sort of everyday usage really. This is the sort of greater than, or less than, or greater than, or equals to, and actually we've got the equality one in there as well, which is kind of very similar to a relational operator. It probably shouldn't be there really because we've already covered it in the equality operator one. But again, like the equality operator, these always return a Boolean, because you're basically just questioning. You're asking a question. You're saying, is this greater than that? So you're going to get a true or false back. It's kind of meaningless to get like a number back or a string. It has to be a Boolean, a yes or a no, true or false. So we basically got 5 of them. These 4 are obvious, sort of greater than, less than, greater than, or equal to. So that's a bit like a compound operator that we looked at before. a little bit like a compound operator, and less than or equal to. So those are sort of fairly obvious. Instance of might not be obvious to all of you, but it probably will be to some of you. That's kind of a special case, and we'll look at that in a minute. It's also a special case because it's a very rare example in Java where for some reason camel case wasn't used. You'd expect it to be like that, instance of, but it isn't. That's just a little quirk. It must have been an early bug or something that never got fixed, and it's now just part of the language. So it's a very rare case of core Java API not using camel case. So instance of all one word. So if we just have a look at those, so it's fairly obvious stuff here. As I said, they all resolve to a Boolean. So here you're saying A is the result of checking whether 3 is less than 1. So 3 is not less than 1, so you'd expect that to be false. And similar with all the rest of these. So 3, so that's, you expect that to be true, and that is false, and that's true. Again, we're using the equality operator here, which we've dealt with in another class, but they're very, very similar. They're checking two things against each other and returning a Boolean. So if you just run that quickly, that is relational operator. Yeah, so just what we expected. Like 3 is not less than 1. 3 is greater than 1. So true, false, true, false. So it's stuff that we, fairly intuitive really. And here we can just show another example of an if statement. We just uncover that. Just show what an if statement looks like. So saying if 3 is less than 1, print that. And if statements can have else, multiple sort of branches to them, else ifs. So you wouldn't expect it to go down there. Else if 3 equals 1, print that. Else if 3 is greater than 1, print that. So you'd very much expect it to do that. You'd be baffled if it got there, because that should cover everything. So if we print that, we're expecting to say 3 is greater than 1. There it is. So it just shows how Boolean, when we start using these conditionals like ifs, Booleans are very much what control them. Like the things in here need to evaluate to a Boolean. So they're fairly straightforward, those ones there, less than, equal to, and equality. Just a quick look at instance of, because it's a bit of a special case. And instance, as the word suggests, you're talking about objects there, because it's objects that are used to create instances, not primitives. So instance of is used on objects. So what we've got here, we've created, if you remember back to we're starting to build this zoo, and we've created an animal, and it's actually a lion. So if you remember, this is the principle of polymorphism. We could just start that as a lion straight from the off if we wanted to, but we're using polymorphism. We don't want to treat at this stage this lion just like a lion. We just want to treat it like at a higher level as an animal for now. As an animal, we just want to treat it as an animal. Tiger is also an animal. So this is how you use instance of. You're saying, okay, if you didn't know that, I mean, you can see it here because it's right in front of you. You can see it's a lion, but you might not, in the real world, you might not have initiated it yourself. You might have had it passed in by some client. You might just get an animal passed in by some client, so you don't know what it actually is. So if you want to check, well, is this a lion or a tiger or something else, you can use instance of, and it's a very defensive way of checking before you do anything else. So we're saying Boolean, right? Is this animal a lion? So we say animal instance of lion. It'll return a true or false, and we're expecting that to return true, of course. And here we're saying, well, is it a tiger? Same again, but this time we're expecting it to return false. So just print those out just to see. And so yeah, it's what we expected. So it is a lion and it's not a tiger. So, and Peter said, this reminds me of when we did the sessions last year, and we kind of got a bit confused about this: is a lion an animal or a tiger and stuff. But we're kind of going back to that again, because what you can do is, once you know it is actually a lion, because at this stage, if you didn't see that right in front of you, you wouldn't know what actual animal it is. But by doing this instance of, you found out, okay, it's a lion. So now that you know it's a lion, you can cast it to a lion. You can say, okay, I now want to start treating this animal as a lion because I know it is a lion. So I can cast it to a lion like that. If we don't have that, it fails because it's not. You can't be sure. This is like an upcast. You're going from a super type to a child type, so you can't just ask Java to do it automatically for you. You have to tell Java, I know this is a line, trust me, convert that to a line for me. If it fails, then it's my fault, but I'm asking you to do it. Now, so would you know what would happen if we tried to do that? We're trying to cast this animal to a tiger. Does anyone know what would happen if you tried to do that? Well, we'll find out. I'll run it now.
Does it complain that it's a lion?
Well, it does. We get one of those, a classic runtime exception, java.lang class cast exception, saying lion cannot be cast to a tiger. So that's exactly what we were talking about. Like we're telling Java here, we're saying, look, trust me, convert that to a tiger. I know it's a tiger, so just do it because I'm telling you to do it. But when it tries to, it finds out that you were wrong. So you get class cast exception. You can't turn that into a tiger because it isn't a tiger. So going back to instance of, that's commonly where you use instance of. They're commonly used as a guard when testing something. So
can I just ask you something? Please,
yeah, sure. If you're so
go
good.
back up a bit.
Yeah.
Yeah, line 59.
59. Yeah.
Where you have assigned the lion to the animal
Oh yeah.
type. If I'm correct, you can access, by doing that, you can access getters and setters of the animal class. Is that correct?
Absolutely. Yeah.
In the example below now, when you're doing the casting,
Yeah.
say my lion. Yeah, so that object now can access methods of the lion class by doing that.
Absolutely. So if you look at this lion class, it's got one extra. So it extends animal. So it's got all the, like the, as you say, the getters and setters from animal. It's also got its own unique method called raw, like lion's raw. So if we go back here at this stage, we can't call that raw method here.
Right, okay.
So absolutely right. So we can call it like getters and setters, as you say,
Yeah.
but we can't call raw like that because it just doesn't exist. It doesn't exist as an animal. But we can do it here. You're absolutely right what you said.
That was the question, actually.
Yeah, that's it. So we can do raw there because now we're treating it as an animal, and that's the principle of polymorphism. Here we're treating that object as an animal. Here we're treating it as a line, but it's the same object. It's the same object being treated in different ways depending on its inheritance hierarchy. So that's absolutely right. Yeah. So this is where you'd use the instance of, really. You've said, like, you're using it as a guard. Like you're saying, well, if it's a tiger, and I've checked that here. Is this animal a tiger? I've checked it here. If it is, then try and cast it to a tiger. But if it isn't, then obviously don't. If you don't have an else, it just doesn't do anything. So that's safe to put that there. You're basically just guarding yourself. And this is one thing we talk about. So the point is that it's done the raw there, but the point is it hasn't given us a class cast exception there because it never went in there. We haven't seen that printed out because it never went in there. In fact, this is another thing. Again, most of you are quite familiar with this, but if you set a breakpoint like that, so in the code, and then I've been pressing the play button, but if you press the bug button, it'll run it obviously as a debugger, so you can see where the code's going. I think it's F8 just to step through. So step through that. Yeah, it does that. And here we are, so we can check, well, does it ever go into our if statement? We know that that's false, so it's not going. It's probably going to just skip it and come here, and there it is. So you know that our debugging has also shown us that it hasn't gone into that. Right, now one other thing to mention, and we're kind of leaping ahead to stuff that's going to be covered in different chapters, but while we're here, I've actually created a new class called elephant here. It's absolutely nothing. Remember, you can have multiple classes in the same file, but it can only have one public class. So if I call that public class element, that won't compile. But you can have as many classes as you want in there, and this is elephant. And notice it doesn't extend animal. It doesn't. It's just our own elephant class that we put right here. It doesn't extend animal. These two, lion and tiger, they do extend animal. So now what we can do is we're saying elephant equals new elephant. So can we let's check if like before we were checking whether this was an instance of a tiger or a lion. Does anyone know what would happen if you tried to see if this elephant is an instance of tiger or lion, or even string? Anyone any idea? Well, do you think it would actually compile, or but just throw a runtime exception, or? Well, I'll show you guys, because it doesn't even compile. The reason it doesn't compile is it says these are incompatible types, like because this elephant class is nothing to do with the animal hierarchy. It's not. We've just declared it here. It's because it's called an elephant. It's misleading. But it's absolutely nothing to do with this lion or tiger or animal here. The lion and tiger both extend from animal, but elephant doesn't. So Java knows that there's no way this elephant could be an instance of tiger, because they're not even on the same inheritance hierarchy. They're not. This doesn't even extend animal. So here, even though animal is not a tiger, it did at least allow us to do that, because it could possibly be a tiger, because we know it's an animal, so it could possibly be a tiger at that point. So it allows us to do the comparison there. It turns out that it isn't. But here, it knows even at compile time that could never be a tiger, because this doesn't even extend animal. So there's no way that could be a tiger. So it doesn't even compile. And similarly, it couldn't be a string. That makes it a bit more obvious why you know, because it seems ridiculous to say is an elephant a string. It seems a bit more obvious why that doesn't fail. That fails compilation. And same again with the lion as well from before. If we try and say is it an instance of string, it won't do it. So anything on its own inheritance tree, it's fine to compare. So that's absolutely fine, because object is obviously the ultimate superclass, but they don't compile. Right, so we're just going to look at logical and conditional operators here. So there's two different types, logical and conditional, but because they're so similar, I've just put them in the same class. And what they are, logical operators are and, so ampersand, or, which is like a pipe, and exclusive or, which is like one of those, forgot what you call that. What's it called? That's carrot? I don't know, but anyway. Yeah, that's what it says. Carrot, that's it, yeah.
Not as an R-R-O-T, C-A-R-E-T, isn't it?
Yeah, that's it, carrot. Carrot. Yeah, that's it. So it's a carrot, so exclusive or. And conditional operators, you just have two of them. It's basically and an or again. We don't have an exclusive or, like, as you'll see why in a minute. It kind of doesn't make sense to. But so the difference between the logical ones and the conditional ones is that you've basically got two of them for conditional. And as I said here in the comments, conditional operators, which are sometimes called short circuit operators, and you'll see why in a minute, why they're called short circuit operators. They're like logical operators, but the right hand side of the equation that they're in might not be evaluated. They're commonly used in guards. That probably sounds like double Dutch at the moment, but we'll explain it. So what we're saying here is, and again, these things you're checking things. You're saying does this and this, is this and this true, or is this or that true? So you again, they evaluate to a Boolean again, just like the other operators we've just been looking at, like relational inequality. So the answer that you get back from doing these things is a true or false again. So here's a couple of Boolean expressions then. You're saying, is 5 less than 3, which it obviously isn't, so A will become false. You're saying, is 6 greater than or equal to 2, as it obviously is, so that's going to be true. Hi Terry, you going to join us?
I'm looking for Tom, actually.
Oh, okay, no problem. So that's always going to be false, and that's always going to be true. So here we're saying is A and B, are they both true? And they're not, so we wouldn't expect that to print out. So say logical and conditional. Just have to create the just run that. So we probably won't expect any output at this stage from that, and there isn't. And we're saying is A or B true? So yeah, we would expect that to output because it's saying either A or B or both are true, because basically that just checks are either one of them or both of them true, and this is an exclusive OR, so it's either A or B but not both. So only if one of them is will that print out, and of course that is true, so that prints out as well. And then we've got the not operator. Remember that's a unary operator that we covered in the last session, where it just reverses what you a Boolean expression. So we're basically asking are both A and B not true? In other words, false. Are they both false? That's basically asking the question: are they both false? So, and they're not, because one of them's true. So at this stage, if we now look at the same thing, but now we've got two of these in here, so they're conditional operators rather than logical operators. These two are exactly the same as these two, and sure enough they actually evaluate the same way. But either A or B are both true. Yeah, that's right. So they evaluate the same way because only that one got printed there. Only that one got printed. So you might think, well, why do we even bother if they basically do the same thing? But basically, the key difference is that with these conditional operators, when you're doing like an AND here, when you're doing an OR actually, if the first one turns out to be true, then it won't even bother checking the second one, because it knows that overall that's going to be true. So if you can imagine having 100 conditions in there, you're saying if this or this or this or this or this or this is true. Well, if it gets to the first one's true, there's just no point doing the rest, because you know that it's that overall it's going to be true because the first one was true. But this one, it does the second one anyway. Even though the first one tells you that it's going to be true. And again, you might think, well, what's the sense in that? So if we just look at some examples that might explain that, we'll see. And it really it applies again more to objects. So I created a new lion object there, lion called Layla there. It's just of our standard zoo classes, and so this time we're using the logical operator. We're saying if lion is not null and lion get name is not null, then print out I'm a lion called get name. So let's just run that. So we've got the and that's true. It prints out as a logical operator. It's printing out that it's a lion called Layla. So that's all fine. And we've got our logical operator is there. We've also got some of the other operators. There's an equality, like a negative equality operator there, and a negative equality operator there. You're checking that something doesn't equal something. So we're starting to see these things all together now. But yeah, so that's all fine. And then if we uncomment this one, we see exactly the same thing here with the conditional operator. Let's print it again. And again, it's exactly the same thing. So right up to now, there's no difference at all between the behaviour of the two. But this is where you'll start to see a difference now. If you actually comment those out, and run those lines again. In fact, let's run one of them at a time just to make it clear. Let's just do this one first. If you run that line now, you get a null, our favourite exception, null pointer exception there, and that's because you said, well, is line null? Well, it actually is null. But because we've got this logical operator, it checks the next thing and tries to print this out. But because that's null, you can't perform an operation on a null object. So that causes a null pointer exception, because you're trying to call the method getName on a null object. So you get a null pointer exception. So let's just do exactly the same thing now with the conditional operator. The only difference between these two statements is that this has got like the double ampersand. So let's run this time, and we get nothing back, and we don't get that exception, and we don't get that printed out either. So let's just introduce a quick else and run it again, and there we go. So by using a conditional and not a logical operator, we avoided a null pointer exception. So what it's done, it's come in here and it said, okay, if line doesn't equal null. Oh, hang on a minute, it does. So don't even bother doing that one. Don't even bother doing that one, because we know straight away that's not going. That's false. So we've got a false here. So we know logically that this whole thing is going to be false later. So we don't even bother doing that one. So that's the key difference between logical and conditional. And what I'd say is that you nearly always see these used in the kind of work we're doing in a business environment. You do see these ones used in a little more mathematical physics environment, because they also serve to shift bit patterns in primitive variables. But that's not beyond the scope of the exam. That's for more people who are that's for sort of more mathematical applications. But in business applications, you'll almost always see these because you know they're more defensive. That's a defensive way of trying to get the details from a line. Because if you just try and do that without checking first if it's not null and everything else, then that's how you fall into getting null pointer exceptions and things like that. So I think we've covered most of those. If we go back to if we go back now to, I think we did everything in that. That was a small one, compound operators. We've just done that one. Relational operators, I think we completed. It's got, we completed that one. So I think just to finish off, we've just got this to go back to this equality operator. So if you remember, when we were looking at this, it was really simple. We were just using double equals to check that two things are the same. I think you get true if they are and false if they're not, and not equals, so that to check that something isn't the same. So, and we were using it on primitives, and it was fairly logical, and we were just saying that to be careful not to confuse it with the assignment operator, because obviously they look the same, but they have a different effect. That just assigns the value of an int, and as it's an int, you will get that returns an int because it's dictated by the type. But this will always return a true or a false. But anyway, we did it with primitives, just using some ints as an example, and the same principles apply to all the other primitives. But now let's look at how you can use it for objects. So what we've got here, we're using just to demonstrate it, we're using the file object, which is a very useful Java class, and we'll use it later in the course, because you can use that class to actually get hold of files on your file system, open them, read to them, write to them, etc. And we're saying to this file object has a constructor where you can pass in the path to the file. So we're saying create me a file object called f1, and this is the file that it points to. So it's like an abstraction of a file. It's like a Java representation of a file. And f2 points to exactly the same file. And f3 points to f1. So again, that is by extension also pointing to that file. So what do you think would happen if we checked for equality on f1 and f2? So if we're saying does this equal that? Do you think it does? False. You think it's false? Okay. So let's just run that again. Yeah, f1 equals f2 equals false, and we'll explain why in a minute. But just before we explain why, what about if we say is f1 and f3? So f1, we're saying f1, sorry, f3 point to f1. So what about this? Are these the same? They're the same, right? So let's just see. Yeah. So these two, that returns false when you try to say are they the same, but this one and this one don't. And we can illustrate that. I think I've got a picture now. I've kind of downloaded that from the Confluence page, so I don't know how well it's. I'll just try and enlarge it a bit as well. Don't know how well it's kind of translated. Try that. Yeah, and this kind of explains it. Yeah. So these are those lines of code we were just looking at before. But I don't think we used X, Y, and Z, but it's the same principle. So what we're saying is, and again, this goes back to some stuff from chapter 1. We're calling them the new keyword. So that's going to create us an object on the heap. So we're saying X. Here's that file, by the way. It's somewhere on our file system, and we're saying create me a variable called X of type file, and point it towards a new object on the heap, and that object on the heap has a variable reference there. So X is pointing to the variable reference of that object. Then Y comes along here. It also calls new, so you get a new file object there with its own reference, and that points to the same file. So logically they're kind of equal. They're looking at the same file. They're both file objects looking at the same file, but actually they're not equal, because basically X and Y are pointing to two different references in memory. So that's why they're not equal. That's why the double equals equality operator returns false, because they're not pointing to the same object. Then this one comes along, Z, and we say, okay, Z, just point to X. So Z points to X, where X is pointing. So Z and X are actually pointing to the very same reference in memory and the very same object. So they are equal, those two. So that's why those two returned true when you tested them for equality. So just going back here again, that's just what we've demonstrated there. It was X, Y, and Z on the other thing. It's F1, F2, F3 here. But there's a bit more to the story than that, because we're testing the assignment operator here, and really you might think, well, actually we want it's silly that these two aren't equal, because they are doing exactly the same thing, and it's kind of like on a technicality that this is returning false, because they're pointing to different references in memory, but actually logically they're doing exactly the same thing. So that's where another method comes in, and that's the method called equals. So let's just uncomment that. Now, if you remember when we looked at garbage collection, we had the option of overriding that method called finalize, and what that does is it gives an object kind of a last request of something to do before it gets destroyed by the garbage collector. And the point is that finalize method is, I don't know if it's to hand here, we can just quickly go into that. Yeah, finalize. That finalize method is it going to open it for me? No, I was hoping it might just open that on the object method, but that finalize method is defined on the object class, so the original superclass of all objects. So here we're overriding it. We're overriding the finalize method. So why did I mention that here? Well, equals is another example of a method that's provided on the object class, and what it does is it provides developers with an opportunity to write a method that will return true if two objects are kind of logically equal. So they're not actually equal here because they're pointing to two different memory references in the memory, so on the heap. So that's why this returns false. But looking at it logically, they're logically very much doing the same thing. They're both file objects. They're both pointing to exactly the same file. So logically, they are equal. And so if we instead of equals there, we use the equals method, and the same for the one below. Let's see what happens now. So this is showing us the difference between equals, the equals operator there, and the equals method on the object class. This time it returns true. That's because the developer who wrote the file method decided, yes, I'm going to override that equals object, that equals method, and I'm going to make it return true if both those objects are pointing to the same file. So that was a decision the developer made. If he hadn't bothered, or he or she hadn't bothered doing that, it would have just reverted to the default implementation of equals, and what that does is it returns the memory reference. So in other words, it would have done exactly the same as this would have done. Exactly the same as this, because it would have compared the memory references of the two. So if the developer hadn't bothered to override that method, then this would be false as well in the same way. But it's like a logical design decision that a developer can make. Well, how do I want people who use my class to be able to determine if these are logically equal or not? So we do deal with that a bit more in later chapters, but it's good to introduce it here and compare, like, equals, the method on the object class, to equals here, which is like the equality operator. So along the same lines, so we've done it for a file object here. Let's look at strings now, because we're obviously more familiar with strings here. Very, very similar pattern here as before. So we're saying S1 is a new string, hello world. S2 is a new string, hello world. S3, point to S1. So very, very similar to the file example. So do you know what would happen if you evaluated these? If you're asking, are these two equal to each other using this equals operator? Does anyone, do you think? False. And here, so you're asking, is this equal to that? Let's see, so let's just check that. Yeah, so exactly the same. So here we have it, false and true, exactly the same as the file example, false and true. So now this is really to demonstrate the peculiarity of strings and the uniqueness of them, because obviously string is one of the most commonly used classes in Java, and it has a few of its own quirky rules and different ways of doing things that other objects can't. Because of course it is an object, it's not a primitive, a string, it is an object. I mean, that proves it's an object, because we're using the new keyword on it here. So here this is very peculiar behavior here, because what we've been doing it right from the first lesson, but we probably just haven't appreciated how peculiar that behavior is, because string is an object, it's not a primitive, and yet here we're not using the new keyword, we're just telling it directly what its value is, and there's no other object that you can do that with. To get an instance of any other object, you always have to use the new keyword. And in fact, even with string, you can use the new keyword. That's what we're doing there. But this is a unique thing to strings. They use so much that the Java have made it possible for you to just do that. So, before we carry on, what do you think will happen if we check these two for equality? S4 and S5 equals the same thing. Anyone? it's like false. Everyone think false? Who thinks true? Alright, so Peter's the only one saying true, I think. And you're right, Peter. You're right, Peter. And that's because it doesn't look intuitive, really. Well, it doesn't look intuitive given what we just discussed, because it looks like we've just done exactly the same as that. But and when I said before we can instantiate strings without using the new keyword, that makes it sound more trivial than it is, because that makes it just sound like, oh yeah, okay, Java put a feature in to do that, so you just don't have to bother with the new keyword. It's just that's the only reason you can do that. There's more to it than that. Strings are so commonly used in Java that Java maintains this string pool in memory. So if that's example diagram we've got with all the different parts of the memory. Another thing we can add on to it, there's like heap, stack, garbage collector, class loader, and all that. Another one is string pool. It's got this structure called a string pool, and if if you use a new string like that, it'll put it in that string pool, so that if you create another string of the same value, it'll check first, or have you already got it in the string pool, and if so, it'll just use that again. So what this does, this creates a new object there, because that's the first time. Well, actually it isn't, because we've got them there as well, but that's beside the point. That's if we didn't have these lines here, that would be creating it for the first time, putting an object in the string pool. And this one comes along, and Java looks in the string pool, sees that literal is already there in a string object, so it doesn't bother creating a new one. It just points that value, points that variable to that one. So in the case of strings, these are equal, but not if you do it the old-fashioned long-winded way like that. In here the same rules apply. Here, by using the new word, you're forcing it to create an object on the heap. It has no choice, because whenever you use that new keyword, you're guaranteed to get a new object, absolutely guaranteed. So here you're effectively saying, look, I know you've got this fancy string pool, but I don't care about this. I want you to do it the old-fashioned way and create a new object. I don't want you to mess around in the string. So you're kind of forcing it not to do it. But if you do that, which is what developers nearly always do, if you look in our test classes and things here, you'll very rarely see strings created like that. You nearly always see them created like that, because it's quicker and easier, and it takes advantage of that string pool. So again, we just for formality, we can check some equality on those. Again, we've checked it with the equals method. With the equals operator, and not surprisingly, they all evaluate as true when you combine them to each other using the equals method, because again, the developers who wrote the string class, well, it's very obvious how you'd implement equals on the string class. You just say, well, if the value of this one string is the same as the other one, then they're logically equal. It doesn't matter if the variable name's different or anything else. You know, the contents is what is the important thing of it. So I think that's it basically for today. I've just noticed there's one there. There's the ternary operator one, which I hadn't really kind of prepared for this session. I think it's quite a simple one to go through. So I'll just leave it till next session, and then we've done the vast majority of Chapter 2. Other things that come into Chapter 2 are like structures like the conditionals, like the if statement, which we've already seen and most people are probably quite familiar with, so that we should rattle through that quite quickly. So there we go. Sorry there wasn't a session last week. Thanks for coming this week, and let me know if there's any questions or anything, and we'll do another session next week. So, thanks guys, thank you.